Good morning, friends. Today we are going to start the very important, the new topic, that is chapter number 3. In the chapter number 3, the name of chapter is, we have to hear, that is magnetostatics. It is very much important topic. In the last period, we have discussed about the chapter number 2, that is electrostatics. And now today we are going to discuss the new topic that is called as a magnetostatics. That topic, magnetostatic, which is related to what we have to say that related to induction, जसं की resistance, capacitance, magnetostatics, which is related to the branch of induction. इंडक्शनच्या ब्रांचच्या रिलेटेड जो टॉपिक आहे त्याला आपण मॅग्नेटोस्टॅटिक असं म्हणतो. मल्टिपल चॉईसमध्ये विचारला जाऊ शकतो. मॅग्नेटोस्टॅटिक्स इज रिलेटेड टू inductance, capacitance, resistance. So what is the option we have? It is related to inductance or induction. And then first definition in this topic we have to discuss, that is called as a magnetic field. Magnetic field. In the magnetic field, an electric current can be passing through the conductor. What will happen? Let us consider one conductor and the electric field is passing through the conductor. At that time we have to say that conductor produces a magnetic effect. When the electric current can be passing through the conductor, it produces the magnetic effect. Means what we have to say that the stress around the current carrying conductor is called as, stress around the current carrying conductor is called as a magnetic field. Stress around the conductor is called as magnetic field. When we have to say that the current carrying conductor we have to consider, and in that electric current can be passing through the conductor, it produces what? A magnetic effect. And that effect means what we have to use? Surrounding space, current space around the surrounding space, that is called as what? A magnetic field. And simply we have to say that multiple choice question may be asked on that again. That is space around the current carrying conductor. Space around the current carrying conductor is called as what? Magnetic field. Space around the current carrying conductor is called as magnetic field. Here, one more question may be asked on that. That is a Lorentz magnetic force is. What is Lorentz magnetic force? That is, we have to say that F bar is equals to Q into V bar cross B bar. This is a Lorentz magnetic force. And that is nothing but what you have to say that F is equals to QVB. And V bar cross B bar is nothing but sine of theta, QVB sine of theta. Multiple choice question may be asked on that. Magnetic force is F QVB. And again we have to say that Lorentz force in a moving charge is given by Lorentz force in a moving charge, that is total force we have to consider. F is equals to electrostatic field force is say E into Q, and magnetic force is this one, that is Fe plus Fb, nothing but we have to say that a Q into bracket V bar cross V bar cross B bar. This is one more multiple choice question asking on that. That is total Lorentz force. Total Lorentz force moving along the charge is considered as say F bar is equals to Q into bracket E bar plus V bar cross B bar. This is the magnetic field force. What we have to say that Lorentz force is given by. In the magnetic field, this is the Lorentz field, and that is Lorentz force in the moving charge. So we have to consider as say F bar is equals to electric field and magnetic field force. That is F bar is equals to F into E bar plus F into what we have to say that B bar. FB plus Fe, that is called as total Lorentz force in the moving charge, that is F bar is equals to Q into bracket E bar plus V bar cross B bar. Then next is we have to say that magnetic flux. Magnetic flux is denoted by the symbol is what we have to say that phi. And what is phi? The total number of magnetic flux, what we have to say that magnetic flux can be defined as the total number of tubes of induction. Total number of tubes of induction. This is what we have to say that tube and total number of tubes of induction passing through the coil. Total number of tubes of induction passing through the coil in a direction perpendicular to the plane. Total number, this is the plane, and what we have to say that total number of tubes of induction passing normally through the field, that is total number of tubes of induction passing through the coil in a direction perpendicular to its plane. This is called as a magnetic flux. Magnetic flux is denoted by the symbol is a phi. Phi is equals to what we have to say that V bar dot A bar. And here B is the magnetic induction and A is called as a surface area. That is the surface area, and this is called as a magnetic induction. Finally, we have to say that F is equals to B into A dot product is nothing but cos of theta. B into A cos of theta. This is called as a magnetic flux, and this can be written in the form of integration also. What we have to say that magnetic flux B is equals to surface integration of B bar dot A bar. Surface integration of B bar dot ds bar mana kiwa B bar dot A bar. Also we have to write that over the surface. Yes, this is magnetic flux can be written. Sometimes multiple choice question may be asking on that. What is the formula for the magnetic flux? Magnetic flux can be denoted by this is B bar dot A bar. This is also QVB sine of theta. This branch is also called as, it is related to what we have to say that induction. Magnetostatics is related to induction. This is the sub formula you have to consider. Then one more question we will ask on that SI unit of magnetic flux is. Weber WB. Multiple choice question will be asked on that. SI unit of magnetic field is Weber. Secondly, we have to say that magnetic induction. Sometimes question may be asked on that. Magnetic induction is denoted by which symbol? Magnetic induction is denoted by symbol B bar. B bar. B bar is called as a magnetic induction. Magnetic induction can be defined as, that is a magnetic flux per unit area. Magnetic flux per unit area. This is what we have to say that phi, and here what we have to say that B bar is equals to phi upon A. B is equals to phi by A. Magnetic flux per unit area, that is called as what? A magnetic induction. Magnetic flux per unit area is called as magnetic induction, and at SI unit is considered as flux is measured in Weber and area is measured in meter square, Weber per meter square, or it is also called as Tesla. And sometimes we have to say that, or we have to say the one more formula for the force. F is equals to IBL. F is equals to IBL, where I be the current flowing through the conductor, L be the length of the element, B is the magnetic induction, and F is the force. Therefore, B is equals to F upon IL, and R, this can be written as force is nothing but Newton, current is measured in ampere, length is measured in meter. Newton per ampere meter is also called as Tesla, or it is also called as Weber per meter square. This is nothing but the magnetic flux per unit area, that is called as a magnetic induction. Basically, it is denoted by the symbol is B. B is called as magnetic induction. And then most important law we are going to discuss here, that is Biot and Savart Law. Sometimes question may be asked on that for 5 marks, that is explain Biot and Savart Law and in detail, or we have to consider here, that is statement and explanation of it, and explain the Biot and Savart Law. First of all, we have to consider here a small element, that is say having length is say dl. Small element having length is dl, and here we have to consider that is a conductor carrying a current. This is a conductor, and that carrying a current is say I, and PBA any point, this PBA any point at a distance is what we have to say that R from the length element say dl, and with making an angle theta with the current carrying conductor and say line joining the point, that is considered as say theta. And finally from this we have to say that dB is called as what? Magnetic induction. And this magnetic induction dB is directly proportional to what we have to say that number one, that is current flowing through the coil, number two, length element dl, number three, making an angle say sine of theta. Magnetic index is directly proportional to these three factors, and it is inversely proportional to what we have to say that r square. So we have to first of all a statement for Biot and Savart law. That is what we have to say that is Biot and Savart law states that the magnetic induction passing through the conductor can be number one, directly proportional to current flowing through the conductor. Number two, it should be directly proportional to the length element dl. It should be directly proportional to the making an angle say theta, and sine of the angle say theta, and it is inversely proportional to, it is means what? Magnetic induction is inversely proportional to say r square. And finally we have to write that is dB is equals to proportionality sign we have to take on here, given out, and say that potential constant is say k, and that is nothing but dl sine of theta divided by r square. But k is the constant of proportionality, having value is say mu 0 upon 4 pi, and here mu 0 upon 4 pi is nothing but what we have to say that a constant, and that constant is called as permeability of the free space. So formula becomes dB is equals to mu 0 upon 4 pi and into ideal sine of theta divided by what we have to say that r square. This is the one more formula for Biot and Savart law, and this factor having value is 10 to the power minus 7, that is Weber per ampere meter. This is the value of say mu 0 upon 4 pi, having value is say 10 to the power minus 7 Weber per ampere or Newton per ampere square. This is the unit for permeability, and permeability is nothing but the permeability of the vacuum or permeability of the free space. Sometimes we have to write the formula for Biot and Savart law. One more form we have to write for the total conductor, that is taking integration of this equation, that is B is equals to mu 0 into I divided by 4 pi, mu 0 into I divided by 4 pi, and that is integration of sine of theta divided by say r square into say dl. This is the one more formula for Biot and Savart law. Sometimes question may be asking on that. That is mu 0 is called as permeability of the vacuum. SI unit of magnetic induction is B चा SI unit आहे वेबर पर मीटर स्क्वेअर किंवा टेस्ला. CGS unit आहे Gauss. This unit of magnetic index is nothing but say Gauss, and then 1 Gauss is equals to 10 to the power minus 4 Tesla. This is the relation between Gauss and Tesla, CGS unit and SI unit. Then vector form of this can be written as mu 0 upon 4 pi mu 0 upon 4 pi dt is equals to mu 0 upon 4 pi ideal bar cross r bar divided by r cube. This is vector form. For a Biot and Savart law. This can also written as, that is the direction of magnetic field d bar is perpendicular to the both the current carrying element dl and pointing vector say r bar, then this can be written as, that is what we have to say, that dB is equals to mu 0 I upon 4 pi mu 0 I upon 4 pi dl bar cross r bar divided by r cube. This is one more formula, that is integral form of a Biot and Savart law. Then we have to say that dimension of B we have to finding here. What is the dimension of B now? Dimension of magnetic induction can be written as, what is the formula for B here? The B having formula is F upon IL. This can be written as F is nothing but M1L1 T raised to minus 2. Current is I is equals to, what we have to say, that I raised to 1 and L raised to 1, and this can be written as M to the power 1, L to the power 0, T to the power minus 2, and here I to the power minus 1 or ampere to the power minus 1. This is the dimension of, say, magnetic induction. T minus 2 and I minus 1. Mu 0 having formula, here also another unit, that is Newton per ampere. Newton per ampere square. So dimension of mu nothing but what we have to say, that this is the dimension we have to consider for the permeability, and then 1 upon 4 pi epsilon 0 having value is remember the one thing, 1 upon 4 pi epsilon 0 having value is 9 into 10 to the power 9. One factor we have to remember, that is Newton meter square per Coulomb square. Then mu 0 into epsilon 0 1 by c square, and this can be written as c is equals to 1 upon under root of mu 0 into epsilon 0. Sometimes speed of light can be calculated by using the same formula. This is called as, say, Biot and Savart law. Remember, all the things are very important here: magnetic field, magnetic flux, magnetic induction, and statement of Biot and Savart law. Remember all the things and multiple choice question. This article is very important in the magnetostatics. Thank you.